Welcome to qnawire.
All right, so the first part, part A, once you defined the magnetic flux through B coil. And so magnetic flux, if you'll remember, is, or calling it phi sub B, is the magnetic field strength B times area A of the coil times cosine small phi. This is the angle relative to the perpendicular axis. Okay, so and then there are n number of coils, so you multiply the whole thing by n. So total magnetic flux total before is phi sub b comma I, denoting initial, is equal to n BA cosine, in this case phi is 0 because it is perpendicular to the coil, is perpendicular to the plane, or so the coil's plane is perpendicular to the Earth's magnetic field. So that's 0, and so this is 200 for the number of turns. Times B in Tesla, it's six times. Whoops, it's 6 times 10 to the negative 5 Tesla, and times area is 12 times 10 to the negative 2 squared. So this will be 12 times 10 to the negative 4 meters squared, because that's an SI unit right there. So the total flux before is 7.2 times 10 to the negative 8 Webers times this 200. So the answer is 1.44 times 10 to the negative 5 Webers. That's the unit. And that is before. And after, you have phi BF, denoting final flux, is NBA again times cosine 90, because it's rotated 90 degrees, and cosine 90 is 0, so this is 0. All right, and in part B, we use the law of electromagnetic induction, which is that the EMF induced is equal to number of turns times the rate of change of magnetic flux over rate of change of magnetic flux. So change of flux over change in time. So this is 200. So this is basically this minus that. And so I can write this down as 1.44 times 10 to the negative 5 Webers. That's the change in flux. As you can see, that minus 0 is that. And so that divided by 0.04 seconds, which is the time taken for the rotation, that's equal to 3.6 times 10 to the negative 4 volts, or 0.36 millivolts.